In the fourth and final lesson in chapter 7, from 7-7, our lesson here, we're going to divide complex numbers. So we have expressions like the one in blue here where you have an I in the numerator and an imaginary number also in the denominator, and we're actually going to kind of almost rationalize a little bit. It's not actually rationalizing, but we're going to do some things similar to what you did with rationalizing back in 7-5, and we're going to try to get rid of this imaginary number in the denominator. So to review with you how you did that, back when you had in lesson 7-5, you had a problem that looked like this, an expression. 3 minus the square root of 6 over 2 plus the square root of 5. And what we did is we multiplied this by the conjugate. In other words, we multiplied both the top and the bottom by the conjugate of the denominator. Instead of 2 plus the square root of 5, we multiplied by 2 minus the square root of 5. And just to remind you, when we did that type of work, we ended up with a real number on the bottom, and we ended up with a rational number, because here are our middle term, because we have the same terms, first and second term, 2 and square root of 5 on both, but because the signs are opposite, our middle term disappeared, so our radical disappeared, and we ended up with a real number underneath as a denominator here. So we're going to use this same idea over here with imaginary numbers. So how does it work? Well, here's what we do. We're going to start then and say, well, the conjugate of 2 minus 3i is 2 plus 3i. So I will multiply both the numerator and denominator by 2 plus 3i. Let's take a look then and multiply this out and see what happens. This is part of the reason why in the last lesson you were doing some binomial times binomial. So on the top, I'm going to distribute. 3 times 2 gives me 6. And then 3 times 3i is plus 9i. Then I have I times 2, so that's plus 2i. And then I have I times 3i, so it's plus 3i squared. All over, that's all my numerator. My denominator, 2 times 2 is 4. Well, then I have a 4 here. I then have 2 times plus 3i is going to be 6i, so plus 6i. Then I have negative 3i times 2 is a minus 6i. And then I have a negative 3i times a positive 3i, so that's minus 9i squared. So what's our next step? We're going to simplify a bunch of things, combine like terms. We're going to try and do this. So let's take a look up at the numerator. 6 is the only real number that's there right now, but I have two like terms if I'm treating I like a variable, 9i plus 2i. So I start with 6, and then 9i plus 2i is 11i. And then I have plus 3i squared, and again a reminder to you, I squared is the same as negative 1. So then 3 times negative 1 is a minus 3. I want my red marker over here. So going back to that. So that would be a negative 3 all over 4 plus 6i minus 6i. Well, here our middle terms disappear. Positive 6i and minus 6i goes away. So I don't have to worry about that. So then I have 4. And then again, I squared is negative 1. So negative 9 times negative 1 is plus 9 equals. All right, so now I'm going to see what I can do on the top. Now on the top, I now have 6 plus 11i minus 3, so that is 3 plus 11i all over 13. Now sometimes I can leave my answer this way, but I do want you to know if you were to actually look at this in the back of the book, it actually splits this into a real number, A, and an imaginary number. 13 in the denominator now means this, I could divide both of these, the 3 and the 11i, both by 13. So we'll break that apart and we'll say this is 3/13, that gives me a real number, plus 11/13 times I, the imaginary number. So now I'm in A plus BI form. So take a look back here. We started by multiplying by the conjugate. Instead of 2 minus 3i, we did it times 2 plus 3i. We did that so the I disappears in the denominator. Why else does it disappear when I have I squared? Because I squared is the same as negative 1. And that's how I ended up with a positive 9. And then I simplified the numerator here. So I got 3 plus 11i all over 13. Broke that apart. So I have a real number a plus bi. All right, next step. Let's take a look at one more. I have one that says 6 over 5i. Well, what's the conjugate of that? Well, if we take a look at 5i itself, if I was to put 5i in the a plus bi form, okay, so 5i, and if I want to change that to a plus bi form, well, what number would I put out in front of 5i? There's nothing there. What number rings nothing? That's 0. So the a plus bi form of 5i is actually 0 plus 5i. Since this is a positive, it's 0 plus 5i. So how do I deal with that? What is the conjugate then of 0 plus 5i? The conjugate then is 0 minus 5i. Then the next question is, do I have to use 0? No, I don't. So here, my denominator being positive 5i, I can then multiply by negative 5i over negative 5i, or I'm sorry, underneath negative 5i. So what happens next in my work? Now I'm going to multiply the top and the bottom, the numerator and denominator. 6 times negative 5 is negative 30, and I on the numerator. Denominator, negative 25, I squared. What happens in my denominator? Again, I now have negative 30 I over, this is like negative 25, and I squared again is negative 1, so it's times negative 1 equals, so we got negative 30i over, and 25, negative 25 times negative 1 is 25. Now, can I simplify the numerator and denominator here? Yes, I can. I can divide both the numerator and denominator by 5, so that is negative 6i over 5. And at this point, I'm done. What would the actual a plus bi form be? It would actually be 0 minus 6/5 I. If I was to put it in, if you see that in an answer key looking like this, 0 minus 6/5 I. That is the same as what we have written right here. Negative 6/5 I is the same as 0 minus 6/5 I. It's the same thing. Okay, that's what you need to know to be doing the last lesson, lesson 4. So here are the problems I want you to work on from your book on that. It's on page 466. It's 33 through 39 all. That's 33 through 39 all. That is what I have shown you in this video. The rest of the problems are just review on the other sections. 43 to 53 odd, 57 to 61 odd, 65, 67, 69. That set, these are the odd numbers because those are review from what you already did in this lesson. When you finish this 4th lesson, you are ready for the progress check for 7-6 and 7-7. I might advise you to take and look over some things from 6-6 or 7-6 and 7-7 before you take the progress check. But when you finish this lesson, now it's time for a progress check. All right, I'll let you get to work on this. Let me know how I can help you.